Hi, welcome to our last section of Chapter 5. We are going to veer off the book a little bit, but basically we're going to be graphing in this section. So if you are a step person, this is for you. So to graph polynomials, you actually already know how to do this. We're just putting it all together. So to graph polynomials, the first thing we're going to do is find and graph the y-intercept. Again, y-intercept is on the y-axis, and that would be when we plug in 0 and find a number for y. Step 2 is find and graph the x-intercepts. Okay. And that's when we will probably factor, we'll probably use some synthetic substitution, factor, and then we're finding all the numbers for x's when y is equal to 0. And then 3, which you already know, is you're going to sketch the end behavior. So when we first did graphing, the x values were going to be 3 and -3, -2. Now we don't have to do anything like that. All we need to know is the x-intercepts, the y-intercept, and the end behavior, and that's it. So all right, so here's just concepts. When I say zeros, that means those are x-intercepts. Factoring, x minus k is a factor, and then we set those factors equal to 0 to find the zeros or the x-intercepts or the solutions. So zeros, solutions, and x-intercepts are all interchangeable. So that's what you have there. Okay. All right, so we'll use example 1 from the book, and then after that we're going to veer off into different examples. But we're going to graph this function. So the first thing we're going to do is find the y-intercept, which means we're going to plug in 0 for our x's. Again, f of x is just a fancy term for y. So we have 0 plus 3 times 0 minus 2 squared. All right, when I simplify that, I get 1/6 times 3 times -2 squared. Make sure you do order of operations first. So we're going to square -2 and get 4. And so we have 1/6 times 3 times 4. And multiplication is commutative, so we can have 1/6 times 12. And that would be 2. So our y-intercept is 2. So when I graph it, x is 0, y-intercept on the y-axis is right there. And then we're going to find the x-intercepts. So let's see. I'm going to bring this down here. Okay. So finding the x-intercepts. And that means we're going to plug in 0 for y because the x-intercepts are on the x-axis. Right, so we have that. We can divide by 1/6. 0 divided by any number is just 0. And then we have x plus 3. And I'm going to rewrite this to x minus 2 times x minus 2. And then to find the x-intercepts, I'm going to set each factor equal to 0 and solve. Right, so here I can subtract 3, and when my x-intercept is -3, these both, the next two are both going to be x equals 2, which means our function is going to bounce when you at x equals 2. So when I go back up here to my graph, I'm going to graph -3 and 2. Okay, and then I'm going to sketch the end behavior. So the end behavior, let's see, what do we have? It's kind of hard to tell, but we basically have 2 x's. We have 2 x's here and an x right here, which means we have our degree for our end behavior is odd. And if we multiply this out, let's see, we'd have 1/6 times x times x. So our leading coefficient is positive, because that would be the 1/6 part. Right? So if it's odd, we're going to start low and end high. and we're just going to make sure we go through the x and y intercepts. So I start here, and then since 2, we have a solution of 2 twice, it's going to bounce right there and go back up. And that is how you graph it. So we'll do a couple more examples to make sure you have it. Local max and local minimum, don't really worry about that. That you will be discovering in pre-calculus and definitely more in calculus. All right, so we're going to graph this one. So please pause it, write it down. This is not in the book. All right, so we have 1, 0, that's -1. So, all right, so we'll get into that more. But first, let's find our y-intercept. So our y-intercept is when we're going to plug in 0 for x. So we have 0 cubed minus 2 times 0 squared minus 0 plus 2. So our y-intercept is 2 again. So I'll graph that, 0, 2 right up there. Our x-intercepts, we need a, we could actually factor by grouping, but we'll do a little bit of practice with synthetic substitution. So if I know a 0 is -1, that's going to go on the outside. And then my coefficients are going to be 1, -2, -1, and 2. So I'm going to drop down the 1, multiply to get -1, add and you get -3. Multiply and you get +3, add you get +2, multiply you get -2, and we did get a 0, which means we did our math right. And then I'm going to rewrite this, 1x squared minus 3x plus 2, and I'm going to factor that to find the other zeros. So this factors into x minus 2 times x minus 1, and you can either do the box or write down the factors to figure that out. And then so I'm going to set these equal to 0 to solve for my other x-intercepts. So if I add 2, I get x equals 2. If I add 1, I get x equals 1. So my x-intercepts are +2, +1, and -1. That's the one they already gave me. So +2, 1, and -1. Right? From there, we're going to sketch the end behavior. So we look at our, let's see, our degree. Our degree is odd, and the leading coefficient, well, technically there's nothing there, but it is a 1, and that means it's positive. So again, I'm going to start low and end high, and I just want to make sure when I do that, I go through all the x and y intercepts. And so there's the graph. Now you could have graphed yours, you could have done a little bit lower. Either way is fine, since we're not worried about local and minimum maximums or minimums. All right, our last example is going to be this one. And so the first thing we want to do is find the y-intercept. You could probably look at it and let me know what the y-intercept is. But when I plug in 0 for all of our x's, their y-intercept is going to be our last number. So our y-intercept, when I plug in 0, I get -6. Okay? And you can pause this and see if you can do this all by your lonesome. But for number 2, we're finding our x-intercepts. We know that one of the factors is x plus 3, and this one has 5 terms, so I can't use any of my other factoring methods. I do need to use synthetic substitution first. So if a factor is x plus 3, then one of my zeros is -3, which means an x-intercept is a -3. And my y-intercept is -6. Let's see. Right about there. Okay. But so I'm going to put -3 on the outside of the synthetic substitution box and my coefficients inside. So I have 3, 10, -3, -20, and -6. So it doesn't skip any. All right, so I drop down the 3, multiply to get -9, add, I get 1, multiply to get -3, add to get -6, multiply to get +18, add to get -2, multiply to get a +6. These do add up to 0, which means I did factor it or did do synthetic substitution correctly. All right, and then I'm going to rewrite. So I have 3, let's see, we started out with a 4th, so this is 1 degree less, so 3x cubed plus 1x squared minus 6x minus 2. Right? So I have 4 terms, and I want to factor by grouping, so I'm going to split these apart. So what's common to the first 2 are x squared, and then inside I'll have a 3x plus 1. What's common to the second set is either 2 or negative 2, but since I want to match my 3x plus 1, I'm going to factor out a negative 2. And so inside I would get 3x plus 1 equals 0. And then when I factor again, see, I factor out the 3x plus 1, and then I put the 2 outsides inside one parenthesis. And then now I have it fully factored, and now I can find my other zeros. So I have 3x plus 1 equals 0, and also x squared minus 2 equals 0. So for first one, I'm going to subtract 1 from both sides. I get 3x equals negative 1, divide by 3. So one of my x-intercepts is negative 1/3. The other 2 are, let's see, I'll add 2 to both sides. I get x squared is equal to positive 2. When I square root both sides, this is going to be x equals plus or minus the square root of 2. And when you're graphing, go ahead and get the decimal, which is plus or minus 1.4. Right? Negative 1/3 is about negative 0.333. So when I graph those x-intercepts, I'm going to get positive 1.4, which is between 1 and 2, a negative 1.4, and I will also get a negative 1/3, which is a number between 0 and 1, or 0 and negative 1. Okay, so I have all my x-intercepts, and notice I did start with a quartic, and I have 4 x-intercepts, which is usually the case. All right, so now we're going to do end behavior. So we have our degree is even. Our leading coefficient is positive, which means the end behavior is going to be up like a cup. So I'm going to start up. I'm going to go through all my x-intercepts. Again, it doesn't matter how low you go. We're just concerned about going through all the x-intercepts, going down to the y-intercept, and then coming back up through the other x-intercept. And that is how you graph them. We're not going to do the guided practice on the notes or in the book. So please pause this and write down this guided practice. And then you could get started on it or wait until in class. Negative 1, 2, 4, and negative 3, those are zeros, so that's what you would put on the outside of the box. For x plus 2 and x plus 4, you're doing the opposite of that, so negative 2 and negative 4. And that is the rest of our lesson.